Now we can see here, this is C. The left type of we can get this B-10 S and B-10 SF plus B-10 minus 1 S power minus 1 plus B1 this S plus B0 now AM S N power n plus AM minus 1 S power m minus 1 plus A1 S plus A0. Now, this is the transfer function of this differential equation. Now, this is the transfer function. Of this n-order difference transfer function. Now here AM minus 1, A1, A0, also this BM minus 1, B1, B0 are quotient, are real number, B, I, A, J, real number. Also this this M is the order M. This is the order of numericity. This order. This is the order. And this N also is the order. This is the order of denominator. Now, in general, M is greater than M. Greater than M. In general. So we should study some some typical element. Study the typical element of complex system. Now there are 6 types of different typical elements. Now these are typical. Element. Typical element. Now the first is proportional element. The first is proportional. Proportional. What I mean proportional? Let's to say this input and the output is proportional. Is proportional. Now let's to say this CT can write as KRT. So it's very important. It's very simple. Now we can see when RT is changed. Now, this CT also is changed. Now, this TT is, this K is a constant number. So, we have to get this transfer function. How to get the transfer function?
The update K, so the unit transfer K equal C of T over B of T.
Now, how to get this back? Now, we can use this Laplace transfer function for this left and also for the right. It is very simple. Now, this the Laplace of CT is CS. Now, this part K can put forward and also is RS. So this transfer function of this proportional element is CS by RS is 1 by K. So the transfer function of proportional element is very simple, 1 by K. The second is initial element. Initial element. Now, what's this initial element? Here we can write it T. This we can show also dCt to dt. Now plus ct equal to RT. Now, what's the transfer function of initial? You can do it on your research book. How to do it? Initial element.
What is to write?
How do you have to do it?
T and TC or RT.
Also, we will do it with also the right and or the left of this equation. We should use the Laplace transfer function. Now, it's T dCt to dt by dt, plus ct, and equal to Laplace RT. And then Laplace is linear. So, equal to T Laplace dCt to dt plus ct. This is equal to RT. How to compute it?
Laplace of
This to what? T is part the Laplace of the first order.
dt over t is Laplace of s, yes, yes.
Because the order is 1, so the power of s is 1. We can see here, there is derivation of this, the order of derivation of this differentiation equation. We can say the order m, power of this is also m. Okay, so this is s, cs plus also cs equal to, where is rs. Now we can see here cs, so we can get ts plus 1 cs equal to rs. And then the total function gs equal to cs by rs equal to 1 by ts plus 1. So the initial element, the total volume of initial element is 1 by ts plus 1. Do you have any question with it? Now, if we have any question? Now, let's go. The third is the integrating element. Integrating element. Integrating element. Oh, what's the meaning of right. CT now it is the integration of RT. Yes, it is CT. Equal to this integration of RT. Inversion of RT. Now, how to get this function function? How to do it? How to do it? Now, let's analyze it. Since CT is the integration of RT, that means RT also is this derivation of CT. So, for the equation right and left, we can use the Laplace transform. Now, for the left, we can get is RS, and for the CS by RS. So this is the definition of transfer function. So if it is equal to 1 by S, it is the 1 by S. We should remember here S is changed. It is not. Do you know? It is the same as the 1 by K?
Yeah, so K equal is?
Is the same?
K
No. This K is a constant number.
And S is not constant.
It's a constant number. But this S is changed. It's a variable. It's a variable. Oh, yes, it's this S. But this K has nothing to do with this. This K has nothing to do with this S. But this S is the same to this S. So these two is not the same. So this transfer function GS equal to 1 by S. This 1 by S is not this 1 by K. Okay, it's the same. This K is a constant number, but this S a variable. A variable. So the two is not the same. The force. Differential element. The differential element include three types. Now, differential element. Now, the first, it is an ideal differential element. The first is ideal differential element. What's the meaning of this? Let's say this GS, this CS, CT is the derivation of RT. This CT equal to dRT by dt. Now we should get this transfer function. How to get it? Also we also use this Laplace transform. It's CT equal to Laplace transform of RT dt. Now the left is CS and the right is S RS. So the transfer function, the definition of transfer function is CS by RS. Now it is equal to S. So the ideal differential element, the GS equal to S. Equal to S. Now I should brush this part. Later, well, if I write on this place,
So I have to.
the students can sickness.
No.
No problem. I have read on this part.
This point is only 4, 3, 4. This can be given like this 3 and 4. This part.
This we read this place can
Yeah.
sickness. Okay.
please go for 1 minute.
Oh, okay.
This is for another classes.
Or maybe, or now this is the also the second differentiating element is first different derived element. First derivative element. Now, it can calculate this CT equal to dRT by dt and plus RT. This is the first order, the first derivative element. Now, this is the ideal differential element.
Yes.
Now, this first derivative element. Now, how to get this transform function? Easy. Would you like to?
I forgot my
Forgot it. What is it easy? 唐静宇，还叫什么名字呢？那个中文名？沙弥摩。
对。
你中文名？Chinese name. Yes. This name is also like a foreign people's name. Now, how to do it? Also, we use the number transform like that. Now, the left is a CT equal to tau dRT dt plus RT. We can get. Where is the CT, CS? This part you can see. Now, this tau S is I, this is Is plus Is. So, the transfer function GS is the CS by Is equal to, we can see here, is a part, is 1, where Is. You can see here it is toward TS plus 1, tau S plus 1. So, the transfer function of first derivative element is tau S plus 1. This transfer function equal to The third is second derivative of element. Derivative element. Second derivative element. Now, for the secondary derivative element with this CT, we can say CT equal to what? We can say here this derivation is for input. The second order of the RT by dt 2 plus, and here to sigma how dr by dt, and plus RT plus RT plus RT. We also can use the Laplace transform for the left and right of this typical element. Now, we use the Laplace transform. Here, the Laplace transform of CT is CS. For this part, we can say here. This is CS. The Laplace transform for this part is T square and S square and CS plus 2C tau S. Oh, sorry. RS. This is RS and plus RS. So here the same RS we can put forward. So the transfer function of secondary derivative element is the transfer function GS equal to CS by RS. So it is equal to 1 by T square S square plus 2S by TS plus 1. So this part we can write it. You can see it clearly and clearly. Okay? Now, for the transfer function, we can use the black diagram for it. Now, here, for this, this is the input, RS, and this is the transfer function, GS, and this is the output, is the CS. General, it is like this. It is like this. So, for this, before brush it, we give this block diagram. Over this typical element. Now we can see for this typical element, proportional element. The block diagram is, we can see here, is K, and the output is CS, and the input is RS. We can see here, this GS is K, the GS is K. Also, for the initial element, we can also say this input is RS, and the transfer function is 1 by TS plus 1. And also this is the output CS.
The block diagram.
Yes, block diagram. Yes, we should use block diagram to analyze control system. Here we should study it. Now for this, the transfer function is 1 by S, and the input RS, and the output is CS. So the block diagram is this. And also for this ideal differential element, this transfer function is S. It's very simple. Now also this is the input RS, and this is the output CS. Also, like this part is the same. This is input tau S plus 1. Our input is RS. This output is CS. And then for this part, we also the same. And the input is RS. 1 by tau square S square plus up to say tau S plus 1. And this is the CS. Now, please review it, and if you have any question, please don't hesitate to tell me. Now we can have a rest.
This one.